Now in this session we go into a bit more detail about the nature of the states, the input signals, and the controlling of the transitions. You know, when does a state get switched to a different state? You know, when does it transition? Okay. Now, previous session towards the end, I talked about for this controller, for this example, very simple example of a finite state machine, FSM, or synonymous, AKA, also known as automaton, finite automaton. So we had 4 possible input signals. Front, meaning that somebody has stepped on the front pad, wants to get in, so the door should open. Okay. Rear, somebody has stepped through the door and has stepped onto the rear pad. That sends a signal. The rear pad has been stepped on. Both, so maybe 2 people or more, have stepped on both the front pad and the rear pad. Okay. And neither, that means there's nobody stepping on the front pad and nobody stepping on the rear pad. Oh, now by the way, implicit, it's not stated explicitly, but implicit in this model is that this doorway is a one-way. People are using it just to come in, that's it. They're not using this door to exit, so it's an entry doorway. That's not spelled out in this in the text, but it's assumed. Okay. All right. Now, okay. So remember this controller, this automaton. It has 2 states. That's all, and therefore you only need 1 bit of information, 1 bit of memory to keep track of its state. Right? You only have 2 states, and 1 bit is sufficient to keep track of which state it is in. For example, 0, if the bit is 0, that could correspond to closed, and 1, the bit 1, could correspond to the state open, for example. Right? Now this controller, with its 2 states, open and closed, they're the labels of its 2 states. Now, depending on the signal that's coming in, that state, whichever it is, can change, to the other state, depending on what the input signal it gets. Now let's do some examples. Now imagine if you were an engineer, it's a computer engineer, systems engineer, and you were asked to design the electromechanical system for an automatic door controller. You would need to think about these things. You'd need to know, well, what states should I use? What input signal should I have? What rules should I have for transition from one state to another? Blah, blah, blah. Okay? So in other words, you need to know how to think in terms of the terminology and the methods and so on of finite automata. Right? So that's what we're learning. Okay. Right. Well, let's do some examples now of transitions and rules of transition. Under what circumstances does a state switch from its current state, the state that it's in now, to the next state, or some future state? Right. So let's say the state is closed, and that would correspond to the door being closed. Okay. So the state of your automaton is closed. And then, let's say the input comes in of neither. In other words, neither pad is being stepped on. Well, common sense, and there's a lot of common sense in this, would be that you keep the door closed, right? If no one wants to use the door, why open it? They're just wasting energy. Heat gets in or out depending on what season it is. Okay, so if the input signal is neither, and the current state is closed, well, the next state should also be closed, right? You just keep the door shut. Common sense, right? So if current state is closed and the signal is neither, stay in the closed state. So the next state would be the same as the current state. Right? So in other words, the two factors, like current state closed and input signal neither, then next state closed. Right? Think of it in those terms. Right? Now similarly, if current state closed and input signal is rear, think of it in common sense terms. What does that mean? Somebody stepped through, okay, and the door was closed, or maybe somebody steps on the rear one. Now this door only opens for people coming into the building. Right? It doesn't open for people wanting to go out. That's assumed. Right? So if somebody steps on the rear pad and the door's closed, we'll keep it closed. Okay. Now that may seem anti-common sense, but it's just for the model, right? It doesn't matter whether it's real world or not. We're just trying to illustrate concepts relating to a finite automaton, states, input signals, transitions from one state to another, rules of transition, stuff like that. All right. Now, if it's closed and the signal both comes in, what do? Well, that means somebody's standing on the rear pad, right, for this to happen. So you don't want to open the door because then you might bump that person on the rear pad. Okay, so you keep the door closed. So the next state would be closed, right? Okay, now if it's closed and your input signal is now front, that means somebody's stepping on the front pad. Common sense says you want to open it. Okay? So that means your state goes through a transition. It switches. It transitions from something to something. It transitions from the current state, which was closed, to the new state, the next state, which is open. Right? In other words, the controller opens the door. Right? So if current state, hold on, where are we? If current state closed and input signal is front, then next state is open. In other words, open the door. Again, common sense, right? So you open the door so the person who's stepping on the front pad can enter into the department store, whatever. Okay. Now, all right. Now here's some more situations that you can happen. If the current state is open, before talking here it was closed, but now if the current state is open, there are only two states. Right? Finite state machine, finite number of states, just two in this case. So if the state now is open and the input signal is front, what do? Well, common sense. What would you do? You just keep the door open, right? Because someone wants to come through. Then it just remains open. So if current state open, input signal is front, then next state is open. In other words, don't change anything. Right? Now if it's current state is open and the input signal is rear, in other words, somebody's stepping on the rear pad, then the next state is open. Does that make sense? Yeah, because maybe they haven't had time enough to get through. They've stepped onto the rear pad, but you don't want the door closing yet because maybe they haven't completely walked through. So keep it open. Right? Now if the current state is open and the input signal is both, that means somebody's on the, or two people at least, right? One's on the front pad, another person's on the rear pad. Now you don't want what are you doing? if it's both, that means somebody's on the front pad. So you want them to be able to come through. Okay, so you keep it open, right? So in other words, if this current state is open, then you have three possibilities. If the input signal is front or rear or both, your next state will remain open, right? Okay. Now, if your current state is open and the input signal is neither, well, in common sense, you should close the door, right? Conserve energy, or whatever, right? Then the state will switch. It'll transition from open to closed. Okay, so there's an example of a transition rule, if you like, from the state open to the state closed. Okay, you're starting to get the picture now? Alright, so let's bring all those little bits and pieces together more. So imagine now, you have your automatic door controller, so your department store, and let's say it starts in state closed, right? And then it receives a sequence of input signals, one after the other in time. Okay, and so the first signal comes in and it's front. Okay? So in other words, somebody stepped on the front pad, and then the second signal, later in time, the rear signal comes in, the rear input signal, and then time is going this way. There's a sequence of signals in time, one after the other. So front, rear, neither, front, both, and so on. Okay, so you have this sequence of signals that comes in. Now, given these sort of transition rules we talked about in the first square here, first half of this session, then the control depend. Now remember, the next state depends on two things: the current state and the input signal. Okay, and you will have rules of transition that you can put in a table, and we will talk about that at the beginning of the next session. A state transition table. But that's the next session. So you can consult that table to figure out what the next state should be, depending on two things: the current state and the input signal. Right? So